All right, so we're on to 10.3, 10.4 assignment. It's about arcs and chords and inscribed angles. So again, just kind of quickly remembering that a chord is a segment with endpoints on a circle. If a chord is not a diameter, then its endpoints divide the circle into a major and a minor arc. So if I look here, F to G is a chord, and so we have the minor arc here, F to G, and then we would have the major arc, F to G. All right, so that's all that one says. Okay. Then we have some theorems about chords, okay, and they're actually pretty easy. So this one says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what that is telling me is if this F to G, let's just say it was 10 inches long, and then let's say J to H was also 10 inches long. So if those chords are the same, then their arcs are also going to be the same. So let's say this was, I don't know, we could just say it's 100 degrees. Then we would know that this one is 100 degrees as well. So if the chords are the same length, then their minor arcs are going to be the same length as well. And flip-flop that too. So like, if we know that the arcs are the same, then their chords would be the same. So looking at this example, I see that LM is equal to JK, and I know arc LM is 75, so that means arc JK would also be 75 degrees. Okay. On this one, because I know this arc DE, right, since DE is equal to FG, because of these little hash marky things, then what that means is that chord DE would be equal to chord FG. So those guys are going to be equal. So then we would come over here and put them equal, and we would go ahead and we would do the algebra. Okay? And I will do that and put that in the PDF. But for time purposes, we're moving on. Okay? So the second theorem that we have here says, okay, if a diameter or a radius of a circle is perpendicular to a chord, then it bisects the chord and the arc. Okay? So when I look down here, right, so from C to B, that would be a radius, or from A to B, that would be a diameter. Okay? And I see that we've got a little 90-degree angle there. That means that it is perpendicular to my chord XY. So if that's the case, then I would know that this piece of the chord is equal to this piece of the chord. It got bisected. So like if this is 5, then this would be 5. And then that's true about the arc as well. So again, if it's perpendicular, right, then this arc, let's just say that arc is 70 degrees, right, then it would be equal to that arc. Okay? So looking over here at this example, right, our radius here, F to D, is perpendicular to chord EG. So because it's perpendicular, then that means that EG got bisected. So this piece would equal this piece, and I could put 3.5 in there. Okay? We would also then know that if this arc up here was, let's say that's 90 degrees, then this one over here would be 90 degrees as well. Okay. All right. Our next example here, it says in circle J. So again, see this notation on how to name a circle, right? The center is J. So in circle J, the measure of arc KLM is 116. Okay, so KLM. So that arc is 116. We know K to M is 15. All right, so this guy right here is 15. It says find the measure of arc KL and segment KN. Well, when I take a look here, J to L is my radius, and it's perpendicular to chord KM. So that means it got bisected. So the whole thing was 15, so each of these then would be 7.5. Okay, and if my entire arc there is 116, then that also got bisected. So then those would be what's half of that? 58. So this would be 58 and this would be 58. All right. All right, another one down here. So this one is not showing the entire radius, but it is showing this little piece here is perpendicular to chord AB. Right, so since it's perpendicular, then AB gets cut into two equal pieces. So this piece would be 4 and this piece would be 4. Okay, now we wanted to find the radius. Okay, well, where is the radius? Well, I could extend this. Okay, and I know that part is 3, but I don't, right? I don't know that. Well, that's not going to help me. I could draw a radius out here. That's not going to help either. So the hint on these ones is to draw the radius so that you can create a right triangle. So if I draw it over here, right, then notice I've got a little right triangle. And I know that side is 3, that side is 4. And we look up our Pythagorean triples, 3, 4, and 5. So our radius would be 5 inches. Okay, so those Pythagorean triples aren't going away. All right, one more theorem here on our chords. So this one says, in the same circle or incongruent circle, chords are congruent if and only if they are equidistant from the center. Okay, so like on this one, if I know L to K is equal to L to Y, so if those two segments are equal, right, then I would know that F to G, right, would be equal to J to H. Okay, so let's say this was like 10 inches, so then this one would be 10 inches. I also see that that segment is perpendicular, as well as down here, so that means it's also bisected, so each of these would get to be 5s. Okay, and one more thing, putting to use what we learned in one of the other theorems, if both of those chords are 10, then both of those arcs are going to be the same. So if that's 120 degrees, then this arc would be 120 degrees. Okay? All right, over here in this example, I notice, hey, that piece is 8, that piece is 8. Oh, okay, then that means that this chord is equal, so QP is going to be equal to RS. Okay? And I know QP or PQ is 3x minus 4, and RS is 14. So those two things would need to be equal. And then again, we would go ahead and do the algebra, and we could figure out what x is. And I'll do that on the PDF version. All right, so on this example, looking up here, it says in circle P. Okay, so in circle P, we know C to E is equal to F to H. So C to E is equal to F to H. Okay, so those chords are the same length. Okay, so therefore, right, these little pieces here must have been equal. So then we would go ahead and put that they are equal, and we would do our algebra to figure out what x is. Okay, and it says find P to G. So once you figure out what x is, then you would go ahead and you would have to plug it back in so that you can figure out how long P to G is. All right, a couple more examples here. So on this one here, it says we want to find the radius. Okay, so you could draw the radius here, you could draw the radius here, you could draw the radius here. Okay, but the most beneficial spot to draw the radius would be to where you can create a right triangle. Okay, so I see a 4 here, a 3 here. So if I draw my radius right there, now I have a right triangle and 3, 4, 5. So the radius is 5. That I think is the same problem as I did a little bit ago. Okay, so on this example here, so there's a couple different ways we could go about this. I know that this arc here is 110. So that means this angle inside of here would be 110. And I know that this angle here is 140. So then this arc would be 140. So that was from last class, where if the central angle is 140, then the intercepted arc is also 140. Okay? Now, I do need to find x and y and z. So the first thing I should probably do is figure out what z would be. Well, here's z. Okay, and notice the red, the green, and the blue are making a full circle, and full circles are 360. Right? I've already used 140, I've already used 110, so that leaves me with 110. So that means arc Z would be 110 degrees. So if that's 110, then the central angle would also be 110. And if that central angle is 110 and that central angle is 110, then their chords are going to be the same. So if this chord is 15, then this chord would also be 15. Okay? All right, last thing that we are going to do here is inscribed angles. So remember, central angles started at the center, right? So this is at the center. So let's say that this was 80 degrees, right? Well, then we knew this arc was 80 degrees, okay? Well, notice this orange angle, that's called an inscribed angle. It says its vertex is on the circle, okay? Now, does this angle right here look like 80 degrees? No, okay? So what the rule is that the angle is half of the arc. So if 80 is the arc here, this angle here would be 40, okay? So the central angles are the same, the inscribed angles are half, okay? And all of these are examples of inscribed angles. So if I knew that this arc was 100 degrees, then the inscribed angle back there would be 50 degrees. If I knew this angle here was 80 degrees, then this intercepted arc would be 160 degrees. We double it, okay? So if this angle in here is 20, then this intercepted arc is 40. All right. Okay, so that's what this theorem is just saying, is that the angle is half of the arc, okay? So some examples over here, okay? So what I would do on this one is, if I want to find this arc right here, what I would do is I would take my pen and I would start at C and I go back, right? So back, and then start at F and go back. So 40 degrees is going to be the inscribed angle. So what is the intercepted arc? 80 degrees, okay? Now I do need to find X over there. So again, I would highlight the sides of angle X. Okay. And angle X is intercepting the arc that's 98 degrees. So if that's 98, then this angle over here would be half. So half of 98, oh, what is that, 48? No, 49. So 49 would be that angle, okay? All right, try another one here. So we want to find out what angle P is, and we want to find out what arc PO is. So here's angle P. So again, highlight it. Okay. Oh, okay. So angle P is intercepting this arc down here, which is 70. So then that angle would be half, 35. Okay. Arc PO. So here's PO. So what angle is making that? So let's go back, go back. So if that's 56, the arc then would be double. So that would be 112. Okay. All right. Now on this one, so a couple things. So I've got an algebraic expression for angle K and angle M, but I don't know angle L. Okay. However, if I highlight angle L, it goes over to here to M and over here to K. And the arc that it is intercepting here is actually a semicircle. And I know semicircles are 180. Okay. So if the semicircle is 180, then angle L here would have to be half of that. So that would be 90 degrees. Okay. And so then I would know that all three of these angles add up to 180. So 5x minus 4 plus 8x minus 10 plus 90 equals 180. And then I would do the algebra there. All right. All right, I'm going to run out of time here, so I'm going to quickly do this one on another video. It'll probably only take me about 2 or 3 minutes.